Hello everyone, we're Group 2 and our project is about investigating key factors influencing student performance. My name is Guna Avula.
I'm Shams Azam.
I'm Samit Brial.
I'm Deepak Beni.
And I'm Sarangi Jairam.
Next slide, please. Okay, so in our research, our main objective is to identify the factors that affect the student's final examination score. So this is going to happen by identifying patterns and relationships that explain what's causing their success or what is challenging them. And the data set we chose was the student performance factors from Kaggle, which has around 6,600 observations. The dependent variable here is the final exam score, which is continuous, and the explanatory variable includes 19 different variables, which six of which are continuous and 13 categorical. Within these, some of them include study habits, additional tutoring, parental education, and so on. And on the right, the table shows a more detailed approach to all of the variables in the data set. Next slide. Okay, so here are the research questions that we tackle, but we'll be getting more into depth as we get to them. Um, but using these research questions, we collectively aim to identify and quantify the factors that significantly affect the student performance. And additionally, we aim to inform educational practices for early intervention and targeted support for struggling students. Next slide. So first I'll be talking about my question, which is, does family income have the same impact on a student's performance across various parental groups? So here, parental groups refers to parental involvement and education. And this is really impactful because the findings could inform policies addressing educational disparities. So we could launch campaigns regarding how parental involvement may mitigate the negative effects of financial hardship. So in the model, we have parental involvement, income, and education, all of which are categorical, and the baselines are underlined. So here, the reduced model doesn't have any interaction effects between each of these variables, while the full model has interaction effects. And for the null hypothesis, we say that the family income places similar impact across all of these parental groups. So this means that there's no interaction effects, and the coefficients for those, so B412 and 1218 are zero. And the alternative hypothesis is the opposite, so there are some interaction terms. Next slide, please. So after these models are set up, the first GLT test is conducted, and there isn't enough evidence to reject the null hypothesis. Furthermore, on the full model, the interaction terms are not linearly significant, which means that we can drop them. This also reinforces the idea that we only need these categories individually. Additionally, with this reduced model, an initial diagnosis is performed, and the points to note are the Shapiro test and the QQ plot, which indicate that the normality was violated. So on the right, you could see in the QQ plot that the end is way off where it's supposed to be. Additionally, as for outliers, the studentized deleted residuals found 37 samples that were Y outliers, and the Cook's distance found close to 2,000 samples that were influential cases, and they were outliers because of that. And some remedial measures were attempted. First, the Box-Cox transformation was integrated, and this failed because of the uninterpretable nature of the coefficients generated, and this was primarily due to the categorical nature of X. Additionally, robust regression was considered as well to deal with influential cases, but this was not actually applied due to the categorical nature of X again. But what did actually work was removing the outliers and influential cases and combining that with bootstrapping. Uh, Removing the outliers not only got rid of the outliers, but it also helped reduce the normality issue, as after you can see on the graph, the QQ plot, that it's the points are much closer to where they're supposed to be. However, to still deal with the lack of non-normality, I implemented bootstrapping for the parameter estimates. Next slide, please. And so for model selection, I used a combination of stepwise regression and k-fold validation. And here, all three of my predictors were selected by this method. So this means there's four parameters, which includes the intercept. And on the right, you can see in the table the estimates for each of these predictors. And the conclusion is, based on the GLT test, that the null hypothesis cannot be rejected. And in context of the problem, this means that the family income has a similar impact regardless of the parental group on the student academic performance. But although there's no interactive effect, the main effect is still significant. So this means that the parental involvement, education, and family income all still have a positive correlation with the performance. However, the limitation is that the model has a very low prediction power just due to the fact that all of these variables are categorical, and also other predictors might not be considered. Finally, the data being self-reported can also cause bias, which can be a limitation.
Hey everyone, I'll talk about the second research question, which is, does the mental health of a student significantly impact their final grades? In terms of practical impacts, there have been several prior works which have shown negative impact of mental health, including depression or sleep on the overall exam scores. Similarly, positive impact has been found when students have support system. Based on these, we form the initial model, which contains one continuous variable, sleep hours, and four categorical variables, motivation level, peer influence, learning disability, and distance from home. We also consider three interaction terms, which includes sleep hours. The null hypothesis is quite simple, where uh, we say whether or not there is a significant impact of these predictors on the exam score, and the alternate hypothesis is that at least one of these predictors has an impact. Uh, a basic GLT test shows that this initial model is significant at alpha of 0.05. Next slide, please. Uh, Using this model, we perform some initial diagnosis for testing the variance, normality, and multicollinearity. And the main thing to point out here is that the normality assumption is violated. Uh, we also recognize some outliers using studentized residual hat matrix and DF-fits. We try a bunch of remedial measures, including box Cox transformations and transformations of X, as well as robust regression and bootstrapping, but none of these seem to solve the normality issue. Finally, removing the outliers and influential plots which were recognized helps improve the normality assumption, as can be seen by the final QQ plot versus the other ones which we saw. So finally, we stick to this remedial measure, and while the normality is not totally improved, totally removed, it is improved. Next slide, please. Uh, After this, we also look at model selection using best subset, stepwise regression, and k-fold validation. And after this step, we drop two interaction terms, which is x7 and x19 and x7 and x9. The GLT test of this final model shows that it is significant, and so does the bootstrapping. Uh, all the predictors are found to be significant except x7, but we do not remove it because of the presence of significant interaction term. Overall, the R square is quite low, which points that we should include other predictors in the model. And the final outcome is that we see quite intuitive results that learning disability is the most significant negative impact on final score, and motivation level and peer influence actually help students improve. And learning and distance from home basically negative impacts the final exam score.
Hi, I did the third research question. So my research question was, does a student's extracurricular activities and habits influence their exam performance? So the goal of this investigation was to uncover whether these factors, whether it's individually or jointly, contribute to academic success. Uh, the extracurricular participation can help students build better life skills like time management and social engagement, and things like cognitive function as well. So the three variables that I considered were, one was participation in extracurricular activities, average hours slept per night, and the average number of hours of physical activity per week. And my null hypothesis is that none of the variables have a significant effect on the final exam score, and the alternative is that at least one variable has a significant effect on the exam scores. So to address this research question, I used a bunch of different rigorous diagnostics to test my regression model. Initially, I started off by checking for normality, constant variance, multicollinearity, and the presence of outliers, and the results were mixed. The model did well for constant variance and multicollinearity, and there was no evidence of heterodisticity, but because all my VIF values were close to 1. which also told us that there was not multicollinearity. However, I found issues with normality, which was evident in the QQ plot, which showed heavy tails, especially on the right side. And there were some outliers flagged through methods like studentized residuals and Cook's distance. To address this issue, I implemented some remedial measures. I started off by doing the box-Cox transformation by phase challenges because it didn't really solve the issue. So instead, I ended up using the robust regression, which solved the issues a little bit, and I also ended up removing a lot of the outliers and influential points. These adjustments greatly improved the model's performance. So for model selection, I use best subset and stepwise regression to select the best predictors, and I perform k-fold cross-validation to ensure the model's accuracy. While the sleep hours contributed a little less than the other factors, it still improved the model. So I decided to keep it. So in the end, extracurriculars activities emerge as a key driver, along with physical activity and sleep hours. These findings emphasize the need for schools and families to adopt a more holistic approach to student development, and schools should encourage participation in these kind of activities. Looking ahead, I'd like to study more specific variables such as what type of physical activity or what type of extracurricular activities have the best correlation with student performance.
I was looking into the question 4. This is Deepak Beni. And the question was, does a student's level of academic engagement and physical activity significantly influence their exam performance? So the practical impact was looking into the academic engagement and physical activity, where the literature says that consistent study habits and higher attendance levels are positively correlated with improved academic performance, similar to the physical activities, which enhances critical thinking and social competence, contributing to better academic outcomes. So the model studied included variables like the attendance of the student, number of tutoring sessions attended by the student, and the hours of physical activity per week. And also the interaction between hours spent studying and the attendance was also attempted. Other variables like sleep hours and other variables also were tried initially, but due to the non-significance of the variables, it was omitted. And the null hypothesis was that none of these variables have a significant effect, and the alternate hypothesis being at least one of these variables has a significant effect on the exam scores. So the methodology adopted was that the initial model summary shows that all variables are significant, and the ANOVA and GLT confirms that H0 can be rejected, and at least one of the variables is significant. Similar to the previous models, I've also attempted most of the diagnostics tests and primarily noted that there's a violation of normality, and I was attempting to resolve the issue of normality. So what was done was using the box score transformations for x and y using log, square, squaring the models 1 by x, etc., and also robust regression and bootstrapping. But unfortunately, none of these methods was helping to solve the issue of normality. So the final remedial measure was by removing the influential outliers using Cook's distance, and normality issue was solved as seen in the chart alongside. And the Shapiro plot also results also gave that the normality issue was almost resolved. General conclusion is that model with all fault predictors or the full model is recommended, and this was validated and selected based on the best subset algorithm. And the final model estimation results are given in the table alongside. The general conclusion is that the model with all variables are significant, and it answers the research question that students' level of academic engagement influences the exam performance. And the interaction terms between X3 and X2 shows that students need to attend the classes and then spend hours for studying the examination. And maximizing the class attendance and engaging in regular tutoring are very critical, and balanced amount of physical activity also support academic outcomes. Thank you.
Hi, I'm Sarangi, and I'm going to investigate research question number 5, which is, do cumulative study habits actually affect the final examination performance score? So the practical impact of this is that research shows that consistency in study habits is extremely vital for final examination performance. And such kind of discipline can basically be tracked by looking at how many classes students attend, which is through percentage of attendance, how many hours they spent on studying by themselves, any tutoring sessions that they attend in addition to classes, as well as their past history on how well they've attempted examinations in the past. So the model will be basically looking at these variables, which are number of hours spent studying, classes attended, and previous examination score, and number of tutoring sessions attended. So coming to experimental design, the null hypothesis states that none of the variables have a significant effect on the final examination score, while the alternative hypothesis states that at least one variable has a significant effect on the examination score. Next slide, please. So for this, a basic GLT test was done, and it did show that the model was significant for a 0.05 value of alpha. Coming to model diagnosis, the following parameters were tested for, including constant variance, normality, multicollinearity, looking at outliers, and influential cases. One point that is to be highlighted here is that non-normality issues were observed in the data set, and therefore they had to be looked at. For this, remedial measures were attempted, including box-cost transformation, robust regression, and bootstrapping. However, none of these really worked and they could not solve the normality issue at all. So, in the end, a final remedial measure that was applied was the removal of influential points that were obtained from Cook's distance evaluation. So, in this case, could you go back to the previous slide, please? So in this case, 130 influential points had been observed in Cook's distance, and the removal of these showed that the normality issues were corrected, and these were also assessed through Shapiro's test as well. Next slide, please. Coming to model selection, 3 of these methods were utilized: best subset algorithm, stepwise regression, and k-fold validation with k equal to a value of 10. And in the end, it was decided that a model with all 4 predictors were performed the best. So the conclusion of this is that the model with all the variables is significant, and therefore cumulative study habits really do have a positive effect on the final examination performance. So now the overall conclusion from our report is that the following parameters: family income, mental health, extracurricular activities like physical activities, sleep functions, academic engagement, and consistent study habits, all of them are extremely vital in determining how well a student will finally perform in their examinations. And therefore, these findings offer really good insights for us to design interventions which can be focused on both academic as well as non-academic factors, especially for the development of support for at-risk students. And therefore, we can also conclude that the promotion of additional features that balances out students' lives, such as physical activity, academic engagement, and mental health, all of these can support overall student well-being and academic success. Thank you.